Hey guys, it's Mrs. Johnson, and I'll be recording a short lesson concerning energy pyramids and the 10% rule. Hopefully, by this point in your science education, you have already thoroughly learned about food chains, food webs, and how they're interconnected. If one organism is added to the system or removed from the system, there is almost always a significant impact on the remaining community. All the energy on Earth originally comes from the sun. Producers or plants can use that radiant energy and turn it into chemical energy, or glucose, that the plant can use. An energy pyramid shape shows the amount of useful energy that enters each level. Each level in a food chain is called a trophic level. The chemical energy in the form of food decreases as it's used by the organisms in that level. Both plant and animal cells need energy to survive and grow. They can break down glucose to release the chemical energy inside. This process is called cellular respiration, which we will get into later. The problem is that even though a lot of energy may be taken in at any level, the energy that is stored and available to the next level is far less. Scientists have calculated an average of 90% of the original energy entering each level is stored and stays at that level. Only 10% of the energy is available to the next level, which is why it's called the 10% rule. For example, a plant will use 90% of that energy it gets from the sun for its own growth and reproduction. When it's eaten by a primary consumer, or an herbivore, only 10% of its energy will go to the animal that eats it. The secondary consumer will use 90% of that energy, and only 10% will go on to the secondary consumer or animal that eats it. By the time you get to the top level, there's only a minor fraction of the original energy. You can see from the slides the energy pyramid can be illustrated in a variety of ways. So now for an example. If we say there's 9,500 kilograms of energy available in the producer level, how much will be available for the primary consumer in the next level? If you're great with math, you would simply take 10% of that number, or in other words, divide by 10. If you said 950 kilograms, you'd be correct. How much would be available at the secondary consumer level? The answer is 95 kilograms. Finally, in the tertiary level, only 9 and 5/10 kilograms of the original energy is left. So if you are that top predator, you would need 9,500 kilograms of plant life to support just you and everything below you, which is why the numbers in each level up are reduced significantly. This is why there are rarely more than 3 or 4 trophic levels. There just wouldn't be enough energy to sustain a population. Now I'll be passing out a simple worksheet to test what you've just heard and watched.